Breaking the Cosmic Speed Limit, published on July 20, 2013. The physics of spacetime described by Einstein's theory of general relativity allows spacetime to become warped due to the relationship between matter, energy density, and the gravitational field described by the Einstein field equations. In the most general form RUV, GUVR to plus GUV equals 8pgic42, which equates that matter and energy found in the large-scale structure of the universe creates a positive torsion in spacetime, causing the warping of spacetime, which is associated with the strength of the gravitational force. In quantum mechanics, zero-point energy fluctuations can create negative energy density, which should theoretically, in a large enough density, create a negative torsion on spacetime in general relativity. The consequences of these theories, when combined, could change our common-sense notions of motion and provide a way to challenge the cosmic speed limit, the speed of light. In 1994, Miguel Alcubierre developed a geodesic equation to describe spacetime warped in a bubble around a ship, creating a warp drive. The warp drive proposed by Alcubierre could achieve near light speeds and even faster than light speeds by distorting spacetime. To accomplish this, a theoretical device would generate a field of negative energy that would squeeze or stretch spacetime, creating the bubble. The bubble would ride the distortions like a surfer on a wave. As evidenced by the uniformity of the cosmic microwave background from the Big Bang, which is explained by inflationary cosmology, spacetime can expand so quickly that objects can move faster than the speed of light. Therefore, the current models of physics generally allow for the existence of a warp field that can accelerate objects faster than the speed of light. The real questions to ask is whether or not such a warp field can exist on macroscopic scales, and if so, can it remain stable for long enough to observe its effects on light in a laser interferometer, for example. Moreover, it is unknown how it is technologically possible. Under what conditions does matter allow for the creation of a negative energy density? The Open Source Speed Limit by Rodney Kavetsky. In this analogy for coming is a description that reinvents the theory of the gravity force physicists have longed to discovering a quantitative formula. It is here in these paragraphs where Rodney Kavetsky has, though unknown at the time, physically unmerited, and in literature rich show mistakes in both Isaac Newton's theory of gravity and also with it Albert Einstein's adjoined infinite mass counterpart. Energy mass postulated unknown at the time, physically unmerited, and in literature rich show mistakes are physically shown. It was over 100 years ago, with accord to this doctrine, when Albert Einstein took an apparently some believe as an absurd observation, the invariant speed of light because it is the fastest deity known, and turned an open force possibility and created barriers and changed knowledge of physical law into a theorem which revolutionized our knowledge of space and the universe. Today, still, we have observations notionally absurd about which point the way to our further understanding. These observations are the linear relationship between redshift and angular size. At high redshift, this linearity should break down but does not. The distance problem that there are more bright objects at high distance than allowed for by standard flat Euclidean geometry. Similarly, that nearby objects z less than 0.5 are fainter than expected, resulting in an accelerating expansion model of the Big Bang. The horizon problem that conditions were similar long ago in very different parts of the universe. Gravity remains ununified with the rest of physical law. Although modeled geometrically, its origin remains unknown. Often overlooked due to familiarity, the absurdity of a model in which things are flying apart from each other at high speed. When Einstein redesigned the theory of gravity using energy free fall as the cause for attraction in Earth's gravity atmosphere, he never speculated how mass energy matter energy decreases and or increases depending on how high it is or how low the object is over the planet's ground. The chart manifest and the change in an object's mass was never postulated or put to scale in his theory or any known theory that explained this course of activity. If it did, we would have found that an object's mass was not all quite definite. that it is possible that the mass in free fall reached a measurable point of zero in the quantitative study and with no action could have changed the whole lot of the theory.
Without this analogy included in his theory, he never observed the factual basis to drop zero velocity, the idea that when a mass reaches the top of its acceleration height, where free fall starts, all forces acting on it cease, even its initial base weight, what it weighs, at rest on the surface floor, inserts its energy account measurement from the 0 point position in the high sky, revising the free fall drop velocity in Newton mechanics. Once the initial acceleration, boost force, and the force applied to its initial mass weight is diminished high in the sky, the mass weight mass as well as its energy content measures zero, where free fall begins and the object tries to regain mass quantities and is the starting point of how Earth's surface energy begins coordinating free fall velocity at 9.8 meters a second per second. He includes in his theory what is known as infinite mass. Infinite mass is the response of energy of a mass when acceleration is constantly implied. Due to gravitation, the mass of the object increases depending on how fast the mass is moving, but due to changes quantum physics study has changed in the theories of gravity, infinite mass as a response of energy does not exist, but is now formally based on the density of space the object travels through as and makes all the difference in the theory of gravitation as a whole. In 1948, theoretical physicists Hendrik Casimir and Dirk Polder proposed that a negative pressure can exist due to quantum vacuum fluctuations operating on very small scales in space and time, and that, if two uncharged metallic plates in a vacuum, placed a few micrometers apart, the quantum fluctuations should create a force between the two plates, due to a differential vacuum energy density between the inside and outside of the plates. In a classical description, the lack of an external field automatically means that there is no field between the plates, and no force would be measured between them. However, when the zero-point field is instead studied using the QED vacuum of quantum electrodynamics, it is seen that the plates do affect the virtual photons which constitute the field, and generate a net force. The force can give either an attraction or a repulsion depending on the specific arrangement of the two plates.
Although the Casimir effect can be expressed in terms of virtual particles interacting with the objects, it is best described and more easily calculated in terms of the zero-point energy of a quantized field in the intervening space between the objects. It was not until 1997, however, that a direct experiment by Steve Lamoureux, described above, quantitatively measured the force to within 15% of the value predicted by the theory. Previous work in the 1970s had observed the force qualitatively, and indirect validation of the predicted Casimir energy had been made by measuring the thickness of liquid helium films by Sabisky and Anderson in 1972. Subsequent experiments with liquid helium-3 approach an accuracy of a few percent. Using Bose-Einstein condensates, it may also be possible to suppress background effects occurring between individual molecules, such as the van der Waals forces, which will help to quantify the necessary boundary conditions in the second quantization calculations of quantum electrodynamics. This would allow the effect of the vacuum to become dominant in the medium and allow for a more direct observation of negative energy density affecting it. This could also allow for further studies in solid-state physics on how the Casimir effect could be controlled at the nanoscale and what physics and applications can be gained from it. Some of this research, although abstract, may help us to understand how electronic transitions occur at the smallest of scales and how to suppress noise, such as that caused by the Casimir effect in nanoscale circuitry, such as in the emergent fields of quantum circuitry.
Therefore, by probing some deep questions of physics and examining theories such as warp drives, we may uncover a great deal of knowledge and gain proposals for some interesting experiments, perhaps even stumbling upon the foundations of warp drive itself along the way. How to break the barrier. In 1994, Miguel Alcubierre developed a geodesic equation to describe spacetime warped in a bubble around a ship, creating a warp drive. Mr. Alcubierre, what I suggest is we look at the idea that space is in an expansion state. If we look at the Hubble theory, space is expanding. How fast, according to Einstein, gravity travels at the speed of light. We look at empty space as a moving continuum and is always moving faster than the object moving. For instance, a ship. The faster the ship accelerates, the faster the space expansion is realized. Even when your ship gets to traveling at close to light velocity, the expansion is still traveling faster. Accordingly, when a ship reaches light speed, it still has the ability to travel even faster because due to the expansion of space, Mathematically, the cosmic speed limit is expanded also. When an object sits afloat, space is moving under it, acting as a fabric like it does with the planet spheres. An impression is formed. Theoretically, the ship isn't moving. Space tells matter to move, causing it to twist, but when we review the acceleration of the vessel, space pushes the vessel faster than its actual speed. We look at the expansion of space with the Hubble's recedings at the same way we look at gravity stretching outwards at an infinitely distant scale, where the celestial gather on the fabric where the width of the universe's expansion is greatly widened causes the galaxies to accelerate faster with the cosmic expansion.
Laugh with me.